Hello, ladies and gentlemen. This is Mr. Prom. I'm going to try to attempt to give you your notes today so that you know what you're doing on the 6.2. But before I do that, I wanted to show you what's here on 6.1b, which is in your notes. I have provided for you some of the parent functions. So everything that you graphed on the worksheet, on worksheet 1, here's a copy of them all for you, just in case your graph was off a little bit. Because I know some of your x equals e to the y, maybe yours did not go through that point right there, which is 1, 0. Or maybe your point didn't go through 0, 1, which it should for y equals e to the x. And so on. So here are all your parent functions that you had. There's one extra here that you have that you won't have to worry about until I teach it to you, which will come up in a different section, so don't worry about this last one, just so you're aware. If you had issues on the quiz today and you messed up and you didn't know some of those parent functions, well, guess what? You get to redo them. And if you need more practice, don't forget there's a Quizlet and there's extra Quizlets. Here is the long link for it. You can find this on my website as well. So that brings us to our notes on 6.2. I actually have a t-shirt that has all this stuff on it. Beautiful dance moves. The sine of x, the cosine of x, the tangent of x, the cotangent of x, the absolute value of x, x squared plus y squared makes a circle. I love it. And so on. Square root of x, square root of negative x. We're going to talk more about that. 1 over x. And that's just crap. There you go. Love it. Okay. So the very first part of 6.2 you are absolutely going to love. You're going to love it because it's so simple that you're going to think, wait, this is too easy. Yes, enjoy it. Okay. Here's a function, f of x equals square root of x plus 8, and then we're going to add 2 to that. Evaluate the function at the specified value of the independent variable and simplify. What does that mean? That means figure out when you plug in -4 into the function, what do you get? So as you look at it, does it mean just plug in the -4? Yes, that's what it means. Plug in the -4 right there. And order of operations says you have to do what's in a group first. This is your group. Think of that. Gotta simplify it first, and then your answer should be 4. The value of f of -4 is 4. Simple? Enjoy it. Try f of 8. Tell the person you're sitting around what you think the answer is. I will give you 10 seconds. If you got 6, you are right. And I know what you're thinking. I like this. This is easy. Yes, I know. Enjoy it. It won't all be easy. Trust me. I know what's coming. So just enjoy these easy questions. And yes, there are some of these on the test. So you can feel confident in it. How could I make it harder? I might throw in an x in there, but it doesn't change how you do the problem. You might have to plug in an x minus 8 into the function and simplify it. I hope you know how to do that. Hard for me to know how much time you need, so I'm just going to go ahead and go for it. If the substitute wants to press pause right now, you can, or unpause it. The answer to this one is root x plus 2. If you need help with that, raise your hand. The substitute will pause the video and then answer any questions you have. For domain and range, what I want to remind you is we've already talked about this, but the domain are your inputs. They're also known as what your x values can be. They are always real x values, not imaginary, not undefined, real x values. That's what our domain is. Our range are our outputs or our y values. In order to find the domain of a function, figure out what values you can plug into your function that would result in a real number, which is basically any negative, any positive, or a 0 as a number. Those are real numbers, anything in between. The domain will always be all real numbers unless there are undefined or imaginary values. These are the two exceptions. So when you're doing problems that I ask you to find the domain, your domain will always be all real numbers unless there are undefined or imaginary values. So I'm going to go into those two things specifically. You're going to have to know those two things and what causes it. An undefined value is created when a quantity is being divided by 0. An imaginary value is created when taking an even root of a negative number. And I'm very specific on this. If you divide something by 0, dividing by 0 is undefined. We'll go more into that, especially into calculus. An imaginary value is created when you're taking an even root of a negative number. That means a square root, or a fourth root, or a sixth root. It doesn't matter if it's a third root, because that's an odd root. Only even roots of negative numbers do not exist. Those are the imaginary ones. So here is an example of some questions that you will have on your homework. It says, find the domain, the inputs of the function in interval notation. What's the domain of f of y? This would be a good time. Also, and what is the domain of g of z? This would be a good time for you to discuss it with your partner and for the sub to press pause. Picking back up, I know what the domain of this is. The domain is from negative infinity to negative 5 unioned with negative 5 to infinity. I can have all the numbers from negative infinity to positive infinity except for negative 5. How come? Because if negative 5 was there, then what would happen is this 3y, I would be dividing by 0. It would be undefined there. What's the domain? There it is. Now for this one we have a couple different things. We cannot have negative numbers, so we cannot square root anything that's going to be negative. Meaning I can use negative 4, that's fine. But I can't have anything that's like negative 6. And as a matter of fact, I can't divide by 0. So this answer, the domain is from negative 5, not including negative 5, all the way to infinity. How come? Because if I had negative 5 in there, negative 5 plus 5 is 0. And square root of 0 is 0. I just can't divide by 0. That would make it undefined. I also can't have any negative values bigger than that, otherwise it wouldn't work. It doesn't matter what goes in the numerator. I can plug in anything I want. It's not going to be undefined or imaginary. Let's try something deeper. What about this one? H of x is equal to the third root of x minus 4. With your partner, discuss. Sub, press pause. When they're ready. Here we go. I can have anything I want inside this one because I can plug in any value from negative infinity to positive infinity. It doesn't matter What about if it's a negative? It doesn't matter because it's a cube root. I can have a negative times a negative times a negative, and negatives work inside odd roots. What about this one? You can't have the square root of any negative numbers. So I have to have values of 4 or higher. Otherwise, if I had 3 in there, 3 minus 4 would be negative 1. I can't square root a negative number because then it would be imaginary. So for your information in your notes, I have odd roots can have negative results, even roots cannot. It's there in case you need it. Piecewise functions. I'm not sure if you have covered this in Math 3 or not. That's what I'm still learning, what was covered in previous sections and what was not. A function defined by 2 or more equations over a specified domain is called a piecewise defined function. When you see a graph on one side and a different graph on another, it's made up of 2 different pieces. As a matter of fact, you've already learned this parent function in 6.1, x squared. The plus 1 means that we shifted that x squared up 1. And we've already learned y equals x, and this minus 1 shifted it down 1 unit. What we're doing now is we're saying we're going to use this function for this domain, and we're going to use this function for this domain, and the function f of x is going to be made up of this piece with that domain and that piece with that domain, creating this gigantic function. That's what a piecewise function is. It is a function made up of different pieces defined by a different domain. Now, if you're going to graph a piecewise function, which is going to be part of your assignment later on, not really in this section, but in future sections, I want you to make sure you know that it's important to identify critical points. The critical points that a calculator would miss, like at x equals 0. In this is what a calculator would give us if we were to punch it in. But I want you to be so specific when you're graphing that you will know where is it defined. Is it equal to this piece over here for the x squared plus 1? When I look at that, is it defined there? Is it equal to the 0? I hope you know what this means for that graph. This is important. And this piece right here, when you look at it, is it equal to that 0 there? Is it defined there? If it is, what you're going to do is you're going to notify me open circles and closed circles. An open circle is a hole. So let's look at what that looks like. There's the open circle. There's the closed circle. Open because it's not defined right there. It's not equal to the 0. It's everything less than 0. And it's closed there to let me know that you know it's still defined. And as a matter of fact, that means this still passes the vertical line test, because even when I get to right there, it only touches in 1 point. Oh, what the heck? I don't know what happened. I don't know what that is. My pencil, I pressed it down. I don't know what that means. I wonder if that drew on there or something. Okay. Sorry. We're going live, so there you go. No mistake. I can't go back, and there we go. Now, here's where it gets harder. If you understood this, you're going to be dealing a lot with this. This is kind of what we're going to be doing. But remember that problem that we had before? I told you that it was easy for a while, and then we get to the harder stuff. Well, this is the harder stuff. I want you to see it. What happens if you have f of negative 2 and you have a piecewise function? Just imagine this is made up of 3 pieces of functions for part of the domain. Normally, I would let you work with each other, but because I'm not there, what I want you to do is think about -2. That's what your input is. So there's not every single place here that you can plug it in. For example, you only use this piece right there, touchscreens. You only use this piece right here for x is less than or equal to 0. Is that less than or equal to 0? So I can only plug that -2 into this piece of the function because -2 is not between 0 and 2. It's also not greater than or equal to 2. So this lets you know what part of the piecewise function you're going to use. Take that 2 and you can only plug it in here, which is only going to give you one result, which makes it a function. Otherwise, it would not be a function. So look at now I touch it and it doesn't go, but when I touched it earlier, it went. Goodness gracious. 2 times -2 is -4 plus 5 is +1. So let's try a couple more of these and see if you get it. F of 0. If you need to pause right now and they can try this. I hope you see that the 0 is equal to 0 there, so I have to plug it into the top equation. I can't plug it in anywhere else. It's not equal to 0 anywhere else. Let's try another one. See if you get it. F of 2. Where is it defined at x equals 2? Can I use that one? Nope. Can I use that one? Is 2 less than 2? Oh, is it equal to 2 here? Well, what's the value going to be? That's an easy one. It looks hard, but it's just 3. And look at how I wrote my answers. F of 1. I think you're starting to get this. Plug it in. 1's here, so it's not in those domains. It's only in this domain, so I only use this middle piece. Plugging it in, I can find that 2 minus 1 squared is 1. F of 1 is 1. Lastly, what if I wrote it in a different way? What if I said, where is my function equal to 0? The hardest one, I put a star here because so many students get this one that I'm pointing at confused with this one down here. This one says, when you plug in 0, what is the value going to be? This one says, where is the function equal to 0? I don't want to know what the input that's equal to 0. That's input of 0. This is an output of 0. Which one of these will give me an output of 0? A little bit harder. So let's show you. I want to find out, is this ever equal to 0? Is this ever equal to 0? Is this ever equal to 0? But there's a stipulation to that. When you do that, when you set this top equal to 0, there's a solution here. When you set the middle equal to 0, there's a solution here. And when you set the bottom equals to 0, there's a solution there. And sometimes not all the solutions are in the domain given. What that means is can I figure out what this is? What's x equal to? If I were to subtract 5 and divide by 2. -5/2, right? What you have to do with that result is you have to check to see, is that part of the domain? Is -5/2, is that less than or equal to 0? Because if it's in the domain, then you can use it. So I can use that. What about this one? If I were to add x squared over here and then square root both sides, there'd be a positive and a negative root of 2. Is that in between 0 and 2? Is that a possibility? If you don't know what the between 0 and 2, what is the square root of 2 as a decimal? It's about 1.4. 1.4 on my calculator. Is 1.4 between 0 and 2? Positive and negative? Is, wait a second, should there be a positive and negative? I feel like there should be a positive value of 1.4. 4. Should there be a negative one there? I believe there's a mistake here. Let me put a negative in front of this. This should not be here. This negative symbol should not be here, should it? If it was negative, it would be negative 1.4. And we can't get 0 unless we use this for negative 1.4, and that is not the same thing. So we should only have the positive there. There's a mistake in your notes. I'm sorry. I'm glad that I was working it out because I get to see it and I go, wait, that's wrong. There's something wrong there. So make sure you know there's only a positive value. Why don't we use the negative value? Because normally everything is plus or minus when we're solving this. Let me work that out real quick. 0 equals 2 minus x squared. I added the x squared equals 2. I square rooted and square rooted. When I square root this, it's the same thing as the absolute value of x is equal to root 2. So then I put plus or minus root 2. It is so important to check, are these in that domain? And apparently I just wrote down plus or minus root 2, and I didn't check to see, well, is negative 1.4 in there? And it's not, so I have to eliminate that possibility. Same goes for this one. 0 will never equal 3, so I can't use that. That will not provide me any solutions. Okay, I hope that makes sense to you. I don't know what's going to happen with this one since I drew on it. Difference quotients. This is the algebra behind the calculus. Literally, you are going to see difference quotients now, and you are going to see them later as well. You're going to see them on this test. This is my favorite review problem to put on future tests, just so you're aware. You will also see it in Calculus Chapter 1 and Calculus Chapter 2 as well. Here's a difference quotient. They give you a function, f of x equals x squared minus 2x. Then they put a comma, and then they're going to give you a rule. Here's the rule. And then they're going to give you a limitation that h cannot equal 0 because otherwise you'd be dividing by 0 and it would be undefined. A difference quotient gives us a function and a formula to follow. Your job is to use algebra to simplify the problem. So here's what you're going to do. You're going to take this function. We're going to use this, and we're going to plug in the 3 plus h into this function. So we're going to take that, and we're going to do f of 3 plus h minus f of 3 over h. And so if you remember, this is where I take the function and replace all the x's, these two things right there, I replace them with 3 plus h. I replace that with 3 plus h. Then I also have to plug in 3 into the function as well, and it's a separate one. So I want you to see this. I think I have it. I have the 3 plus h squared minus 2 times 3 plus h. This piece right here is the same thing as this piece. Plugging in the 3 plus h into this piece and this piece of our function. And then I had to plug in 3 into that function as well. I plugged the 3 in there, the 3 in there, and that's where I got this boxed piece. There's the boxed piece. And that's the hardest part. The hardest part for most students is just plugging this stuff into that function. So if you need time right now for your partner to explain it to you, I'd ask the sub to pause it and for you to explain to each other. I'm going to move on. And now I'm just going to do the algebra. I'm going to FOIL this piece, which is 3 plus h squared is 3 plus h times 3 plus h. I'm going to distribute this. I'm going to simplify that, which looks like this. 9 plus 6h plus h squared minus 6 minus 2h. 9 minus 6 is 3. And then I'm going to simplify it. And I have h squared. 9 minus 6 is 3. 3 minus 3 goes away. So I have h squared, and then the 6h and minus 2h is 4h. And if I do this right, something should factor out of the numerator and the denominator, which I can factor. And h and h, because it's multiplication now we can reduce. You cannot reduce here because it's not groups of multiplication. And so h plus 4 is what our answer is, with the limitation that h cannot equal 0. For your final answers, I always want to get what does it simplify to, and do not forget to write down what h cannot be. Well, h can't be 0. Whatever that limitation is, it needs to be part of your answer. This is a full credit answer. If you forget the h cannot equal 0, it's a -1 on a test, so you are aware. I have an extra example here for you to try with your partner. Substitute teacher, I have to break this up into another video, so you will need to play the next video after this because the bell's going to ring.